Okay. In the last part, we talked about three variables K-map. In this part, if you have four variables, then you can create a box like this. And please remember, the 1 1 will be in the third column, and for in this side, 1 1 will be in the third row. And another thing is, you can group like this one also with the eight eight inputs, and also like this also. So these two and these two. Okay, and the next part is, if you have one in each of the corners, then you can also group with that inputs, like this one, this one, this one, and this one. And again, in the last video I already said that if one is common in both group, it is completely okay. So please remember, as long as there is isolated one, you need to create a group of 2, 4, 8, or 2 to the power n types of group. So these are some example of the grouping. In the next part, actually in the digital electronic, it often happens that certain input condition can never occur, and that condition we call it as a don't care condition, and we express that condition with this D. You can see, so this D here, these are actually a don't care condition, and this can be used to advantage in the design of our logic circuit. So you can include them in your group for your designing. So if there is actually there is 2D and 2 1, so you can make a group of 4. So it will not create any problem with your designing, but it will actually help you to make the circuit more simpler. And the rest of the rules are same. So you can see here that these are the min terms and these are actually the don't cares. So in this position you will have 1, and this position you will have D. So now in the lab work we'll try to design this expression in our circuit. So you can see that there are also some min terms with 1, and also there's some don't care. Okay, so this is actually our function, and if you put it in the truth table like this, so you'll have that in 0, 3 and 14 position you have D. So 0, 3 and 14 position we have D, and 1, 2, 4 and 15 position we have 1. So 1, 2, 4 and 15. So first of all, let's create a K-map. So as there is 4 variables, we have to create a box of 16. Okay. Okay. So now I will put the MSB, that means most significant bit, here is A and B in this side, and LSB, lowest significant bit, in this side, which is C and D. So if we write the expression, it will be like 0 0, which is A bar B bar, 0 1, which is A bar and B. There will be 1 0, which is A B bar, and this one is actually AB, which is 1 1. So 0 0 0 1 1 0 1 1, and this side is also similar. So CD bar, C bar D, then C D bar and C D, which is 0 0 0 1 1 0, sorry, 1 0 and 1 1. Now we will put the inputs over here. So you see 1 2. So if you, here is 1, here is 1, this is D and this is D. Okay, so another one is, here is 1. Okay, now D 1. So this is actually if you write down the name over here like this. Okay, so 0 1 2 3 4 5 6 7 8 9 10 11 12 13 14 and 15. Okay, so we have 14 15 D. So here is 14, so 14 is D and 15 is 1. So if we make some group from here, so we have, there is a, this one, we can make a group of these 4, and we have this group, and again we have this group. Actually this rest of our are actually 0. Okay, now from this K map we will make the expression, right? So first of all, take this group and you can see clearly that in this group C and D both are changing and A bar and B bar is not changing actually. So now if is equal to A bar B bar. Okay, now or take this group, in this group here B is changing, so A bar is not changing, so A bar, and from here actually nothing is changing, so C D bar. Okay, this is done. Now next part is this one. From this case AB is fixed, so AB, and here actually D is changing, so we will take C. So this is our simplest expression. Now from this expression we can make circuit. So first of all we have A B bar, so this will go to a AND. So we have A B, so we need to use some inverter over here. And this will go to a AND gate. Okay, next part is A bar, C bar and D bar. So we need C, D, and also we need some inverter. Okay, now it will go to a 3 input AND gate. Okay, from here we can take the A bar. So this is not connected. We can put it here. Okay, so this is done. Last one is A, B and C. So we need another 3 input AND gate. So from here we can take the A. From here we can take the B. And we can take the C from here. Okay, so this is our AND combination, and this all goes to our OR input. So we need a 3 input OR gate. Okay, so this is our F. So now our next target is to implement this circuit in Proteus. So here is our Proteus software. So what we use one 2 input AND gate, 3 input AND gate, one LED which is this one, logic toggle which is this one, NOT gate, this inverter you can see over here, and 3 input OR gate. So if you go to the library list, so if you write AND, so you can see that this is actually normally 2 input AND gate, and you will also find 3 input AND gate. So AND underscore 3, and same case for OR gate. So here is 3 input OR gate. Okay, so as from the circuit, so you can see that in this place, actually in this place we are getting A bar and B bar, this one. So this is this one, and in the next place we are getting the A bar, C bar and D bar. You can see it's coming from A bar, next one is C bar, and the third one is D bar. Okay, and the next one is A, B, C, A, B, C. So you can see A goes here, A, then goes B, and this one is the C. And all the AND gate output goes to a 3 input OR gate, and this is our output. Now we need to check the truth table. So let's simulate this one. Okay, so you can see that in 0000, also 40, this is D actually showing us some output which is 1. So as it is don't care, so we will not take it as a considerable output. So let's check the second one. So 000, so D is 1. So if I make it D1, so this is output is 1. So that is true. And the next case is 0010. So 1 0. Then output is also 1. So this is actually same as our truth table. So the 0011 is don't care. So 0011 is don't care, is showing out some output. As we are in the K map, we consider D as 1. Okay, so now let's check this one, 0100, 0100. So this is 1, which is true. Now next one is 0101, 0101. So this is 0. So actually it's our circuit is actually following the truth table. And let's check this one, 1101, 1 0 1, so that is also false, which is 0. Next one, triple one 0, so triple one 0, don't care, so it's gives some output. And for all inputs are 1, so this is true. So what we designed from the expression is working perfectly. So that's all from this experiment, and you have to complete the report, and here you will find a new expression, and you have to solve it, make the truth table, and you have to make also simulate in the Proteus. Thank you all.